Okay, let's look at the homework 11.5, problem number 2. Right, so let's test this alternating series for convergence. Alright, so let's do a alternating series test. Alright, and the first thing we need to check is that the Bn is a decreasing sequence. Right, so we need to identify Bn. So this is going to be equal to summation n goes from 1 to infinity and -1 to the n minus 1. Alright, so let's look at the pattern. Alright, so this guy is B1. Right, so this is B1. And here, this is B2. And this is B3. I think that's enough. Alright, so it looks like it's a fraction, and the numerator is always 1, and denominator always have square root. Right, so index is 1, it's 2, 2, 3, and 3, 4. So you want to have index plus 1. Right, so our Bn is this guy right here. Right, so it is easy to show that this is a decreasing sequence. So you have Bn is 1 over square root of n plus 1. Right, if you want to find the Bn plus 1, then it would be 1 over square root of n plus 1 plus 1, so it's n plus 2. Right, so since the denominator is larger here, so the fraction is going to be smaller. So this is for all n, a natural number n. Right, so this one checks out. The second condition is we have to make sure that the limit of Bn is equal to 0. So let's compute that. Alright, so Bn, as we found that it's a 1 over square root of n plus 1 as n approaches infinity. But we know that the numerator stays as 1 and denominator gets larger and larger, so it's going to approach 0. Right? So it checks out. So therefore, by alternating series tests, since both conditions are met, we know that the series in question converges. Right? So let's type it in. So this series is a convergent alternating series. Right? So let's check submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.